Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called The Fate of Three Worlds, and it's a refined version of this. So you might have done one previously, and this is by Playmaker6174. So you might have done one previously, though I heard it's like basically 2 years old, and Playmaker basically decided to refine it so that it was, I guess, more clear in its structure and how it actually solved, I guess. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. And we have digits along an arrow summed to the digit in the circle cell attached to that arrow. So, for example, if this were, say, 3 and 4, this would have to be 7, because the digits along the arrow must sum to the digit in the circle attached to that arrow. And 3 and 4 add up to 7, so therefore this is 7, if that were the case. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, for these arrows, the interesting aspect is where 9 can never be on an arrow portion of these arrows. Because if it were, well, the thing is, each one of these arrows is a sum of at least 2 digits on the arrow. And so 9 plus another digit, as long as it's not 0, which none of these digits can be, cannot ever add up to another digit. So we can eliminate 9 from all the arrows, possibly. So that means these can never be 9. So, where are the 9s possible? Also, we have 3 digits here. We have 3 digits in certain boxes, which add up to another single digit. So this must be 1 through 6 here. These have to be 1 through 6 here. And these add up to 6, 7, 8, or 9 as the digits that it adds up to. So this is 1 through 6 here. This is 6 through 9. Okay. Um, hmm. What else do we have? This digit has to be the sum of 2 unique digits here. Where is the 9, actually? In... These two sum up to this digit here. These two sum up to this digit here. So either this digit, it cannot be on the arrow, it cannot be any of these 3 cells. So this digit has to be on the arrow here, or is the same digit as that one. That's interesting. We know 9 has to be one of these two digits here in box 1. If the 9 is here, that means 9 can't be here. Hmm. 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 The sum of these digits cannot be more than 17. But does that help us anything? Not really. Um, so one of these two is a 9 here, because there's no other place for it in row 1. One of these two is a 9, because there's no other place for it in box 1. One of these two is a 9, because there's no other place for it in column 3. Hmm. Hmm. This has to be 5 through 9, because there are at least 4 other digits that are smaller than it. This is 4 through 9, because there are at least 3 other digits that are smaller than it, because these must add up to this, and these two must add up to that. Same with this is 5 through 9. Um, what's interesting is if this is 9, so either this is 9 here, but if the 9 is not here, that means this must be 9. And this can't be 9. So where can 8 be in column 3? Well, since this is no longer 9, this can't be 1 and 8 to add up to it. Neither can this. And this can't be 9, so this would no longer be 8 to add up to this. So this is guaranteed to be 8 or 9 here, right? Again, either this is 9 or this is 9. And in this case, when this is 9, 8, this can't be 9 here, so this can't be 1 and 8. 8 can't be here. 8 can't be here because it only adds up to 9 for two unique digits summing up together. So therefore, this would have to be 8. Okay. Do we have anything similar anywhere else? If this is, so one of these is 9. If this is 9, 8 can be anywhere. Otherwise, this is not 9, so therefore 9 would have to be here. And where could 8 be? 8 could not be any of these. 8 could not be here because they can only add up to 9 on an arrow. And this can't be 9, so therefore that would be 8. So this is 8 or 9 here. And it's the same digit as this one because it's the same situation, right? If this is 9, this is 8 and 8. If this is not 9, this has to be 9, which means that can't be 9, so that's 9. So this is the same digit as this. But, so that means one of those 3 has to be the same digit. This digit means this can't be here, but it could be any of these 6 technically. Um, hmm. So these pairs of digits add up to either 8 or 9, right? And it's the same digit no matter what. So if this is 8, these have to be these if these are 8, obviously this is 9. This would be a 172635 triplet, which would force this to be 4. This would be a 1726 or 35 triplet. Does that mean anything, though, for us? I am not sure. Hmm. This digit cannot be any of these, obviously, so it's one of these 4. Cannot be here or here. Hmm. Um. Interestingly enough, if this is 9, that means this can't be 9, so 9 would have to be here, which means this couldn't be 9, so 9 would have to be here. So you'd have a 9 here, a 9 here. This would be 9 then. That doesn't help us too much. Can this ever be 1, 2, 3? That would force this to be 4, 5, 6. You'd have a 1, 2, 3, 1, 2, 3 triplet pair here. And I don't think that works. So say we had 1, 2, and 3 here. That would add up to 6 here. This would have to be, I guess it could be 4, 5, and then that would be 6. So I guess that's possible. So we have 1, 2, 3 here. This is guaranteed to be 4, 5. That's 9. This would be 6 with 1, 2, so that would be 9. And this would have to be 7 or 8. And then this would have to be 9. But that doesn't work. Because these two digits must add up to the same sum if these are 9. So that's interesting. So either this is 9, or these two digits must add up to 9, because we have 9 here, these two add up to 9, these two add up to 9, these two add up to 9, that's a 9. Therefore, these two must add up to 9. So then this would be 3 through 8 here, with this to add up to 9. Oh, interesting. That does... Okay, so this cannot be 9. If this is 9, these two add up to 9, these two add up to 9, so do these, and so do these. Therefore, these two must be 9. So these two add up to 9, these two add up to 9. We are guaranteed 2 of these have to add up to 9 because we have a 9 here, right? And we have these two adding up to 9, these two adding up to 9. At least 2 of these have to add up to 9 because everything else adds up to 9, if that's the case. So this cannot be 9 here and here. Does that make sense? So maybe it's better to mark them as pairs, right? If this is 9, this must be 9 here. These must add up to 9. These must add up to 9. These must add up to 9. Since all of these add up to 9, this is 30. This is 9 times 4 here, which is 36. So these two must add up to 9. So these two add up to 9. These two add up to 9. And we have these 4 digits must add up to 45 minus 27, which is 18, right? But we know this is at a singleton adding up with 1. So this would have to be 8 at most. So that's 8 plus 10, which that can't be. So this cannot be 9 then. So these have to be 8. So these are 8, which forces this to be a 9 here. And these must be a 1, 7, 2, 6, 3, 5 sextuplet. So is this 1, 7, 2, 6, 3, 5. And that leaves this as a 4 here. So this cannot have a 4, which means it cannot add up to 7, because that would be 1, 2, and 3 adding up to 7. It cannot be 6 here, because if this is 6 here, this would therefore add up to 1, 2, and 3, and that would force this to be at minimum 5 and 6, which obviously can't add up to 8. So you can't have 1, 2, 5 here either, because if this is 1, 2, 5, that would eliminate 1, 7, 2, 6, and 3, 5 as possibilities for this 8 arrow, and that's not allowed. So this must be either 1, 2, 6 or 1, 3, 5, both adding up to 9. So this is not red, which means 8 is one of these two. This is guaranteed to have a 1, so this cannot be 1. So this is not 1 or 7. We have a 1, 2, 3, 5, 6 quintuplet in box 1, which eliminates 1, 2, 3, 5, 6 in the rest of the box. So this can't be 1, 2, 3, 5, 6. Therefore, it's 7 and 1 here. That eliminates 1 and 7 here. No 1 and 7 here. We don't know what this is. So this is 4, which means it cannot have 4, 5, or 6 here. We have to have 2 digits from 1, 2, and 3 here. And this can't be 6 anymore. Because anytime you have 3 digits adding up to another digit, you're guaranteed 2 of those digits are from 1, 2, and 3. This can't be 1 because of 1 in the row. Remaining digits in row 1. Technically, you could have any digit from 1, 2, or 3 here also. Okay. This is 8. That's 8. That's fine. One of these is 8. Remaining digits in box 4. We have 2, 3, 4, 5, 6, 7, 8. Obviously, 8 cannot be either of these. This can't be 2. We could have a 1 here. So this could be anything from 1 through 6 to add up to 8. Can these digits be these digits? So these digits, they're either going to be here or here. Blue's still not helpful right now. So let's remove blue. We can remove 8s. So where are these digits here? They're going to be in column 3. They're either going to be these or these. Assume they're these. Where are they in box 4? They would both have to be here, but we know an 8 is guaranteed to be one of these. So this pair cannot be the digits here. They have to be the digits here, which means those must be some of those digits here. That means we have 3 digits here. So 2 out of those 3 have to be the same as these, which means 2 out of those 3 have to be here. So this cannot be ever 2, 3, 5, or 6, because the green have to be here. These are green. They have to be matched this one, and therefore must match one of these two. And these pink must be here and here, so they must be here. So this cannot actually ever be 2, 3, 5, or 6, because they both see pink and green. So this is 1 or 4, interestingly enough. And this cannot be 2, 3, 5, or 6 because of that problem. So 4 could be 1 and 3. 7. So what are the possibilities here? 4 can be 1 or 3. That's possible. 7 would have to be 1, 6, or 3, 4. And 8 would be 1, 7, or 4. It can't be 4. It would be 1, 7. Interesting. So can these ever be 4? If this is 4, I guess so, right? This obviously can't be 6 or 5, because if this is 6 here, that would be at minimum 2 and 3. Same with 5, and therefore it would not add up to a digit. Nine cannot be here. So where's 9 in box 6? It must be one of these two, which eliminates 9 from the rest of the column. But any of these could be 9. Any of these could be 9, technically. Any of these 3, actually. Interesting. Okay. 1 cannot be here. So 1 has to be obviously one of these 4. But that's not that helpful either. Oh, interesting. No, that doesn't help us too much. We do have some information. Okay. Where are 7, 8, and 9 going to be in row 1? 9 obviously can't be either of these, because it can't be on an arrow. So 9 has to be one of these two. Where are the 7 and 8? They can't be here. Only one of them can be here, so the other one has to be in one of these arrows. Well, since the 7 or 8 has to be on one of these arrows, they must add up to a digit higher than 7 and 8. But these cannot be 7 or 8 here because of the 7, 8 in the row. So we have to have a 9 somewhere here. And since we know 9 is here, that means this has to be 9 here, which means this can't be 9. Therefore, this must be 9, and it must have a 7 or 8 with it, which makes this 1 and 2 to add up to it. So we have a 9 here, a 9 here. Where is the 9 in column 7? It must be either here or here. That's kind of interesting. 9 is here, so this can't be 9 anymore. So this must be 9 here, which makes this 2 and 3 adding up with 4 to add up to 9. That eliminates 2, 3, and the rest of the row. So this can't be 2 or 3. This is 5 or 6 with 2 or 3 there. This can't be the other 7 or 8, because if it tries to, that it's not going to add up to a digit greater than 9. So this has to be 7 or 8 there. This has to be 6 or less. So, and it cannot be 1, 2. So this is 6, 5, or 4 here. And this is guaranteed to have either a 1 or a 2 here, right? It's either 1, it add up to 4, it would be 1, 3. To add up to 5, it would be 1, 4, or 2, 3, which requires a 1 or 2. And to add up to 6, it would require 1, 5, or 2, 4, which would require a 1 or 2. So the rest of the box cannot contain 1 or 2. Remaining digits in row 1 are 1, 5, and 6. So this can't be 6 here. To add up to 4 would be 1 and 3. To add up to... So this, I think, always has to have a 1. 5... Yeah, if this is not 1 here, this would have to be 5 and 1 to add up to 6. So either way, this is guaranteed to have a 1, which means this cannot be 1. This is 2 and 7 adding up to 9, which forces this to be 8. So there's no 8 here. 8 cannot be here. This has to be, it's either 1, 3, 1, 4, or 1, 5 to add up to 6. And where is the 6 in row 1? It must be one of these two digits, which eliminates 6 in the rest of the box. 2 eliminates 2 as a possibility here, so this can't be 2. It's 3 and 5, which adds up to 8. So this must be a 3-5 pair here, which eliminates 3, 5 in the rest of the column. So this is 2, 6 as a pair. This can't be 3 or 5. This is 1, 2 as a pair. 2 eliminates 2 here, so that's 1, which makes that 2. This 1 and 2 eliminates 1 and 2 here, and it can't be 5, so that's 6. 5 eliminates 5 here, so that's 1, which means this can't be 1. And this can't be 3 because of 3 in the row, so this is 4, 5, which adds up to 5 or 6 here. Where is 3 in box 3? It can't be here because of 3 in the row, so 3 has to be here. That leaves this as 4, 5, or 6 here. We cannot be 5 because this is either 1, 4 adding up to 5 or 1, 5 adding up to 6. So this is 4 or 6 here. This cannot be 3 or 5 because of 3 or 5 in the column. So this has to be 6 or 7 here. So this cannot be 4. And it must be adding with 1 to adding up to 6 or 7. Oh, sorry, 7 or 8. That means one of these is guaranteed to be 7, which eliminates 7 in the rest of the box. Because it's either 1, 6 adding up to 7 or 1, 7 adding up to 8 here. So this cannot be 7 here. This can't be 9 because of 9 in the column. So to add up to this arrow, you're guaranteed you have to have a 1 to add up to 6 or 8, right? 6 requires 1, 2, and 3 to add up to 6, and 8 requires 1, 2, 5, or 1, 3, 4, both of which require a 1. So we have a 1 here. Therefore, this must have a 1 here. And we have a 6, 7, 8 triplet in row 6, which eliminates 6, 7, and 8 in the rest of the row. So this cannot be 1 plus 8 adding up to 9, so this can't be 9, which means this is 9 here. This must be 1 and 2 adding up to 3, 1 and 3 adding up to 4, 1 and 4 adding up to 5, and nothing adding up to 6 could work. So 5 is guaranteed to be one of these two, so this can't be 5, which means this is either 1, 2 adding up to 3 or 1, 3 adding up to 4. Either way, we are guaranteed a 3 in one of these cells. So this is 3, which eliminates 3 in the rest of the row. This can't be 3. That's 5 and 3 there. This is not 6 here. It's 1 with 2 and 3, or 2, 5, or 2 or 3, 4. We don't know which. Remaining digits in row 6 cannot have 1, cannot have 3, cannot have 5, 6, 7, 8. So that's 2, 4, and 9. With a guaranteed 9 here. Okay. Let's see. This cannot have 1, it cannot have 3, so it's either 2, 7, or 4, 5 here. And it cannot be 2, 7 because these 2, 7 eliminate that possibility. So this is 4, 5, which eliminates 4, 5 in the rest of the row. So this can't be 4, it's 8. This can't be 8, it's 7, which makes this 6. No 6s here, it's 2, 4 as a pair. 6 eliminates 6 here, so that's 8. 4, 5 eliminates 4 here, so that's 3, which makes this 1, and that 2. That eliminates 2 here. So we have a 4, 9 pair in box 5, which eliminates 3, 4. 1, 3, 4 as a possibility to add up to 8. So this is 1, 2, 5, which eliminates 2, 5 in the rest of the row. So this can't be 2. This is 4, which makes this can't be 4. It's 2. Remaining digits in row 4, actually box 6, has to be 6, 7, 8. And this can't be 8, no 7 here because of 8 and 7 in the column. That leaves a 3 remaining in row 4. So this is 3, which makes this 2, which makes that 3. Remaining digits of row 5 are 6 and 7. 9 is one of these two. We don't know which. Remaining digits of column 2. We have 7 and 9. Remaining digits of column 1. We have 3, 4, 5. Okay. Okay. Remaining digits of row 3 are 1, 5, 1, 4, 5, 6. This can't be 1 because of 1 in the column. Remaining digits of row 2 are 4, 5, 6, 7, 8. No 8 here because of 8 in the column. Okay. Can this ever be 5? The answer is no, because if you had 5 here, you would have to have 1, 4, and 2, 3 here, and that would eliminate all possibilities for that cell. So no 5. Can it be 6? No, because if this is 6, it would have to be 1, 5, and 2, 4 as possibilities here, and the 6 and the 2, 4 would eliminate 2 and 6 there, so that would eliminate all possibilities for that cell. So no 6. So we have a 7, 9 pair in row 9. Interesting. Where is 1? In box 9. Cannot be here, cannot be here. So 1 cannot be here because of 1 in the row. So this must be 1 here. This cannot ever have an 8 then. Because if we had an 8 here, it would have to be with 1 to add up to 9. But we already have a 1 in the box. So none of these can be 8, which means 8 in box 9 has to be one of these two digits. Whereas 8 in box, well, in row 9 now, cannot be here because this must add up to 9 with 1. Sorry, it must add up with 1 to add up to 9 in that row. But that's not possible because of 1 in the box. Can't be here or here because 8 in the column, and 8 here would force that to be a 1 to add up to 9. So neither of these can be 1. So this must be 8 here, which eliminates 8 from being here. Where is 8 in column 5? It has to be here. Okay. Remaining digits of column 6, we have 2 through 7. So this could be 3 through 8 here to add with the 1. But this can't be 7, so this can't be 6 here. 3, 4, 6, 8 all kind of work. This can't be 8, though. We have 3, 4, 5, 6, no 8, because this can't add up to... Oh, we need a 1 somewhere in row 9. Well, can't be here, can't be here, so 1 has to be here. And then this cannot be adding up to 9 here, so this must be 1 and 6 adding up to 7, which makes that a 9 here. 7 eliminates 7 here, so it's 9 and 7. This adds up to 7, so it's either 5 with 2 or 3, 4 together. And 6 eliminates 6 here, so this is 2 and 6. That means this cannot be 2 and 5 adding up to 7, so this is 3 and 4, which eliminates 3, 4, and the rest of the box, and the rest of the row. So this can't be 3 or 4, which makes this 5. Therefore, there's no 5 here. This must add up to 5, 6, or 8. Cannot be 6 because of 6 in the row now. So this must be either 1, 4 adding up to 5 or 1, 7 adding up to 8. Cannot be 7 because of 7 already in the row. So this is 1, 4 adding up to 5, which makes this not 4. That's 3 and 4. 4 and 6 eliminate 4 and 6 in the column, so this can't be 4 or 6. It's 5. This can't be 4, 5, or 6. It's 7. 5 eliminates 5 here, so that's 2, which makes that 5, and this makes this 3. 5 eliminates 5 here, so that's 6. 5 also eliminates 5 here, so it's 4 and 5. 7 eliminates 7 here, so it's 6, which makes this 8, which makes that 7. 6 eliminates 6 here, so that's 4, which makes this 5, and 6 there. 3 eliminates 3 here, so it's 4 and 3. This is 8, that's 2. 1 eliminates 1 here. This can't be 5 or 6 then, also because of 5 or 6 in the row, so this is 4, which makes that 1, and that's 6. 6 eliminates 6 here, so it's 7 and 6. 4 eliminates 4 here, so it's 9 and 4. We have all the 1s. 2, we have 8, 2, so the last 2 is there. 3, we have all 9 3s. 4, we have all the 4s. 5, we have 8, 5, so the last 5 is there. 6s, we have all the 6s. 7s require 7 to be there, and therefore this is a 9. Yep, fairly straightforward. Wait, was this a hard puzzle, or was this a... I think this was supposed to be hard, but it didn't seem that hard to me. I don't know. I mean, it's just... The break-in was kind of interesting, but it was fairly easy to deduce just because of how these arrows sort of landed, and that these had to be adding up to the same sum. And then once you got that, everything flowed from that. I don't know. I don't necessarily think this would be this is hard difficulty. I feel like this is more challenging level. Anyways, that's just what I think. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.